Hi, I just wanted to jump on and create a short video about Chapter 8. Chapter 8 gets into dental imaging characteristics and starts on page 72 of your book. And hoping that with this video, it will help to clarify or explain things a little bit better. We're getting into some pretty heavy content, and some of the terminology that's going to be used can get a little confusing. So hopefully this will help. So one thing I do want to make sure that you have a pretty good understanding of is how to distinguish between what would be radiolucent and what would be radiopaque on an X-ray. We talked a little bit about these two terms that week prior to spring break, and just want to make sure that you can be able to identify and determine what structures on an X-ray would X-ray radiolucent and what would show up as radiopaque. So when we talk about radiolucent, we're talking about those images that are going to appear black or dark in color, and that's due to basically it being less dense and allowing the X-ray to penetrate through. So structures that are going to appear radiolucent on an X-ray are going to be any airspace. Your pulp is going to appear a little bit darker in color. Any pathology like an abscess or even a cyst is going to occur and look a little bit radiolucent on an X-ray. Radiopaque are those structures that are going to appear white or lighter in color, and that's due to it being more dense and not allowing the X-ray to penetrate through. And those structures are going to be like your dentin, your enamel, your bone. It's also going to be restorations like amalgam, composite, even crowns, full gold crown, and also porcelain crowns are going to appear white or lighter in color on an X-ray. So it's very important that you are able to identify those because it's going to make you a much, much better assistant in the long run. The next thing I want to get into is being able to determine what would be considered kilovoltage and what is milliamperage. Kilovoltage is depicted by the abbreviation kV, and milliamperage is abbreviated MA. So if you see those two abbreviations throughout your book, please know that it's referring to kilovoltage and milliamperage. So the way to determine the difference between the two and what they are is, if you think about kilovoltage is the energy that's produced to create something. Without that energy, you can't produce anything. So it's the amount of energy being produced. Your milliamperage is referring to the quantity or the amount. And in this case, we're talking about X-rays. So it's the quantity or the amount of the X-ray beam as a result of the kilovoltage. So milliamperage goes hand in hand with kilovoltage, because if you increase your kV, you're increasing your energy production. You're going to have a higher or an increase in your milliamperage, which is going to result in higher density. If you decrease your kV, it's producing less amount of energy, so you're going to have a less penetrating X-ray that's being emitted from the machine, which is resulting in a decrease or lower density. You can kind of identify that based on, it's going to be more so with your conventional film, just because that kilovoltage and milliamperage really plays a part in that. One other thing that we're adding to the whole basically density portion of it is also the exposure time. We now do not have the capability to adjust our kV and milliamperage. Those come automatically preset on our X-ray machines, which is kind of nice because we don't have to worry about increasing or decreasing those to make sure our X-ray is going to come out just fine. But we do have to make sure that we're being mindful of the exposure time. And the exposure time occurs when you have to make sure that if you're taking an x-ray of the anterior teeth, you're switching it from the posterior setting. And if you're taking an anterior or posterior tooth x-ray, then you need to make sure you're switching it back to the posterior setting. And then there's also a separate setting for bite wings. So when you change those settings, I want you to pay attention to how it increases or decreases the exposure time. And that's going to matter because if you're using a posterior setting on the anterior teeth, more than likely your x-ray is going to come out a little bit darker. If you're using a anterior setting on a posterior tooth, or even a bite wing setting on a posterior tooth, your x-ray is probably going to come out a little bit lighter because of the density of it. So one thing that we do have control of is exposure time, and just making sure that you are changing whether it's maxillary or mandibular, posterior, anterior, or bite wing, because that's going to matter with the density of the x-ray being produced. So just a recap, increase in kilovoltage kV increases your quantity of the x-ray being emitted, your milliamperage or MA, which then is going to increase the density. If you decrease the kilovoltage, you're decreasing the quantity or amount of the x-ray beam that's being emitted from the machine, resulting in a decrease in your density. Your book has some really great helpful hints that I encourage you to look at with each of your chapters as we're going through the book. It kind of explains things a little bit differently and hopefully makes it easier for you to understand. In regards to kilovoltage, it uses the analogy of a nozzle on a hose, that when you open up the nozzle, you're decreasing the kilovoltage, creating more of a mist. A mist on a hose, if you're trying to wash away something, the mist isn't gonna cut it. It doesn't have enough power to be able to do so. If you increase your kV, it says you're basically closing the nozzle slightly so that a steady stream of the water is coming out, and that's going to be more penetrating or more powerful, especially if you're trying to wash something away. So again, encourage you, look at those helpful hints, because that will really help explain these kind of technical, complex content a little bit easier for you. Next, we're going to look at contrast. And contrast, the way to think of contrast is it has to do with the detail, the various shades of the density. And when we're looking at, we talked about if we have low kV or low energy that's being produced, it's going to result in higher contrast. And that contrast is going to basically, on an x-ray, you can determine, because it's going to have basically two shades. It's going to have black and it's going to have white. It's going to be very distinct with just those two shades. That's considered, when it has high contrast with the black and the white, that's going to be considered a short scale, because there's only the two colors that are going to be very, very distinct. So low kV results in a higher contrast, which is going to turn up as black and white. It's going to be very prominent, very distinct, and that's going to be considered your short scale. If you have high kV, it's going to result in low contrast, and that's going to be shown because there's going to be a lot of different variations of grays, and that's considered your long scale, because as opposed to your low kV, high contrast, now your high kV, low contrast is now going to have various shades of gray. So you have definitely more shades than just your black and white. So this one would be considered your long scale. Short scale is low kV, high contrast, has two very distinct black and white, short scale, because there's only two colors that's going to be more prominent on your x-ray. Your high KV results in low contrast because it's going to have a lot of different variations of gray. And because of those variations, there's several, which is resulting in a long scale. Short scale is your high contrast. Low contrast, due to the variations of the grays, is going to be your long scale. So again, your book has a helpful hint on hopefully explaining it and making it easier for you to understand. But contrast has to do with the different variations of density. Next thing we're covering is sharpness, and sharpness has to do with basically the detail of the x-ray. And the sharpness is going to be influenced by three different things. It's the focal spot size, which is predetermined by the manufacturer, but they try to use the smallest focal spot size as possible because that's going to create a less amount of penumbra. Penumbra has to do with the blurriness of something. If the focal spot size is a lot larger, your penumbra is going to be increased, which results in a less sharper of an image or a little bit more blurriness around the edges. If you have a smaller focal spot size, it's going to result in less penumbra, which is going to result in a sharper image. Another thing that can influence that is your film composition, and that's going to be true mostly for using still conventional film because we want to make sure that we're using the fastest speed possible, but we know that with the fastest speed of film that we're using, those silver halide crystals are going to be larger, which can often result in less sharpness than your lower speed film. Your sensors, digital sensors, are roughly in between. And then the last one is going to be due based on movement. So obviously if the patient moves as they're taking the x-ray, if the tube head happens to drift as you're taking the x-ray, that's going to result in the x-ray being blurry as well. And oftentimes if it's to the extent where it's pretty bad, then more than likely it's going to have to be a retake. So that's why we have to make sure our patients are still, and we try to move quickly to avoid any kind of movement so that it doesn't mess with the detail or the sharpness of our x-ray. Next, we're talking about magnification, and magnification is based off of two things. First is your target receptor distance, and then the second is going to be your object receptor distance. So when we talk about target receptor distance, this is where our PID comes into play. And remember, we said that the 16-inch PID is much better versus our 8-inch PID. Our longer PID, the 16-inch, is going to result in less magnification because it's restricting that beam to the full length of that 16-inch, which results in less magnification on the x-ray. Our shorter PID, because it's shorter, allows for the x-ray to kind of converge outward, which is then going to result in higher magnification. Any currently newer dental x-ray machines actually have the focal spot sort of recessed, so it's going to be more towards the back of the tube head. So if an office is using the 8-inch PID, because of that focal spot being more back towards the back of the machine, it's going to result in less magnification, and that's the reason why they did that, because sometimes the 16-inch can be a little bulky. It's harder to sort of line up just because it seems like it's so far away from the patient because it's so much longer. So because of that recess of that focal spot point, we're still able to get a pretty decent image because they've now recessed that focal spot back, allowing for the use of a 8-inch PID to come into play. Next is how far or close the film is in conjunction with the tooth. That's going to matter as far as the magnification of an image. And lastly is distortion, and that's just basically angulation, either too short or too long.